Good morning, guys. It's Navi joining the call. Can you guys hear me? Could you please type in the chat window? Great. Thank you, Rahul. Let's get started. Sorry about the delay. And let's see where we are. Thank you, Nitesh. Let's see. We'll start with a little bit of Docker, then get on to the code build today. So, Rahul, maybe we'll start with you, buddy. Can you go ahead and make you the co-host? Okay, you're already the co-host. You should be able to share your screen, log into the AWS and share the screen, please.
Yeah.
Thank you. Pardon me. Okay. So let's see where it will be. Let's try. Here we go. I think we're performing the Docker commands in. You think it is in?
Not too yet.
Okay, please go ahead and log into that, Rahul. And start with history. Read a curl. What do you think is Docker Compose, Rahul?
Docker Compose is used to create multiple containers at once.
Okay, good one. Good answer. Rather than creating each container at one time, we are running multiple. We're composing multiple things. That's also for this orchestration. More sophisticated tool is Kubernetes. We're slowly heading towards it, but Docker Compose is a good start for that. Okay. A few basic questions again, one more time. Rahul, what is a container?
Container is like a lightweight VM which do not contain operating system. It only contains the software and the dependent libraries.
Excellent. What is the advantage of that?
We can run that container in any environment. It will perform same mostly.
Very good. It itself acts like an environment, and that can be plugged into any other environments. And what is the main advantage of that?
It can perform same in dev, prod, and any environment.
Very good answer. So in other words, you will never run into out of sync issues with multiple environments.
Yes,
if it works in one environment, it should almost work in any other environment from a container perspective. Is what it is. Okay. And let's see. Give me a high-level architecture of the exam voting application.
In voting application, we were running this voting container, result container, worker container, Redis container, and Postgres container. So when we the Redis the voting container was connected to the Redis app and Redis container, and that Redis container pushes the data to the Postgres, and the worker container integrates the Redis container, Postgres container, and it's and that result container shows the result, and it is connected to that Postgres container.
Excellent, excellent. What do you think is one of the main problems that we faced here? Tough question. I'll give you a hint. How about the result application?
Yeah, the problem was that it is not showing the result as expected. It is showing 100% for dog. And
so what do you think you will do?
It is the task of the application team, not ours.
Good. More precisely, it is it will be the developer's role, whoever developed it, is what it is. Yeah. Here's a slightly, going a little bit deep, and so maybe a slightly tough question. Can a container have multiple applications inside it?
Container can have multiple applications. We
And
can run that each application on different ports if you want.
okay, so good answer. So short and sweet. We can also have multiple applications in one container, and we can have all these applications also into one container, Rahul. Okay, as simple as that. Can you scroll up a little bit, please? See if there's something. What does link do?
Yeah, links the container which we are creating to the container which is running in the background or anywhere.
More precisely, it is linking the DB database with the result application. It's telling which one is the container. A DB container is what it is telling for the result app. Okay. Okay, as simple as that. And let's see. I think that should be good. Let me see. Docker compose, access and test. Okay, app setup. Okay. And let's see. Can you bring up your browser and just type in gcr.io?
GCR.
GCR, yes. gcr.io. Okay, what do you think this one is, Rahul?
Yeah, this looks like a container registry for Google Cloud.
Good answer. What is it similar to?
It is similar to Docker registry.
As simple as that. So the Google guys have their own containers put here, and they maintain this registry. Docker is maintained by a separate one. Okay. Now let's see. Take a look at. I have sent you a command in the chat window. Can you try to run that? Back to terminal. D4. Pardon me. I'm sorry. D for Docker.
Okay.
It is pulling. Okay. Can you take a look at the command and can you take a guess what it is doing?
We are running this Ubuntu container and we are specifying the CPU. CPU, yes. Basically, we are running this Ubuntu container.
First point is good. Okay. Second point, you almost answered it.
Yeah, we are specifying this CPU.
CPU 0.5. What is 0.5?
0.5 is it is half size of the CPU. Like we specify 3 vCPUs, 4 vCPUs. It is half.
In other words, 50% of the CPUs is going to be allocated to run this container. Okay.
Yes.
So this is resource allocation of the containers. Run the next one also, please.
Sorry.
Run the next one. Next command.
Okay.
Oh, sorry. What do you think that is?
Yeah, we are specifying this time memory.
As simple as that. We're giving 100 meg to Ubuntu. Go ahead and look at the running containers. Okay, status created command and things like that. These are the running containers. Do ps-a. Looks like it exited. Why did it exit immediately?
Because maybe we are not running in interactive mode, or there is nothing.
Very good, Rahul. Good one there. And let's say another one. Run this, please. Okay. Verify the container. Okay, so now how do you verify? Do you know what is Tomcat?
No, no, sir.
Okay, it's like a web server or an application server. How do you verify that that is running or not?
Yeah, it is through status. We can see it is up.
Okay, that is one way. Let's say, what does port mapping remind you of?
Okay, port mapping. Yeah, so we can go and check on the browser. Maybe.
Verify it, please.
Maybe we need to open this portal in security.
Okay, in the meantime, go ahead and open the port. Cool.
Yes.
Okay. So we verified it. Okay, let's see. Back to terminal. Say Docker exec. First find out the container ready, please. Copy the container ready. Yeah. Now say Docker exec space ps.
Yes.
Sorry, container ID. Here's the container ID. Now space ps process status and
Yes.
yeah, ps space hyphen e for elephant, a for apple, f for fox, eaf. Do you remember what does the exec do?
Yeah, we can execute commands inside that inside the content.
Okay, run it. That's a good one. Okay, so notice UID, PID, PPID, and things like that. What is it? This is actually giving us all the processes which are running inside the container.
Yes. Okay.
When you run the Docker PS, what does the command names resemble? Command names, are you referring to the last ones? Command names, cat, command and names. Command is, are you referring to catalina.sh run value? Oh, those are nothing but the namespaces. So that is a shell script, and a shell script which is being run when you run the Tomcat Docker, and those are also referred as the namespaces. The entry points are triggered when you run the container. there's a class or something where the entry point is triggered inside the container, inside the applications. That is what it is, Ankit. Are you catching it, Ankit? Okay, as simple as that. There's nothing. That is what the development team goes ahead and decides what they would like to call and things like that. As simple as that. So coming back here, these are all this just gives the process which are running inside a container, as simple as that. Remember, a container is itself acting like a lightweight VM. Lightweight VM can have multiple processes. So this is one process and it is running under root.
Yes.
And a couple of them running here. Root and let's say, so under the root is like the parent process in the container. A little bit about the internals of the container, and the PID one. Under this process, many other processes run. So at a slightly high level, that is how the containerization is achieved or accomplished. Or in other words, the container itself runs a parent process ID with a PID 1, and under that there might be many other process IDs which are running. So that is how the container uses the parent ID in itself to track all the child process and things like that, and tries to keep something alive, something up and running, or maybe something detects that something is down and things like that. That's a little bit of internal theory, but just an FYI. Okay. Now let's say PS minus EAF, we have root of 50 and the PID is another one is 1. Yes. Just type in PS space hyphen EAF, PS space hyphen EAF, enter. So these are all the things which are running within our Ubuntu server is what it is. Bring up the same command and grep for docker hyphen Java, docker hyphen Java, enter. And there is docker Java and docker Java home. So that is one. In our server, that is one which is running the docker. It's as simple as that.
Okay.
And let's see, what's the PID? Root is 84075. So its process ID is different. Again, this is at the server level, or the different one is what it is. Okay. Now let's say do a list lsltr of /var/lib/docker. /lib/docker. And notice, so all the Docker, all its folders and things like that are here, the runtimes, plugins, image, trust, and so on. The image is where it stores all the images. The volumes is where it stores all the volumes. Go into each of these folders and just have a quick look. Start with the runtimes. Or you can probably list the runtimes instead of going into that one. Cool, nothing in runtimes, okay. Plugins is okay. I don't know if you have any plugins here. Yeah, okay, temp and storage. Okay, we'll come back to that. That should be good. I'm going to images. That's a slightly important one. Images and volume is the containers is another one, which is going to be important. So image overlay 2. Okay, that's okay. Go to the next one. Trust. It's just an FYI. I think all these certificates might be stored here. Then network, slightly important. This file's okay. Swarm is also an orchestration tool, or not much. Then build kit, you can, okay. We'll just do it for sake of discipline. And looks like we got a bunch of stuff in build kit. Okay. All the build information is probably getting stored here. Haven't really looked into it. And the next one, what is the next one?
Volumes, PMP overlay.
Yeah, volumes is important. Go into that. So all the volumes will get stored here. And give me one moment here. I don't have AUFs here. We need to look into these things, but okay, go to the next one. TMP and containers. Nothing. Okay, next one is containers. Pardon me. Okay, so these are the containers. Whatever the containers we are running, it's creating the folders and things like that. And just type in Docker space info. And let's see what we have. So what do you think is this one?
Yeah, it is giving all the containers which are running and details about them, like containers, number of containers.
Very good answer. So whatever we were now just now looking at at a directory level, trying to understand what are the containers, how many containers are there, how many volumes are there. It's a snapshot of the Docker information of the Docker host. Catching it?
Yes.
Okay, let's see, scroll a little bit down. Kernel version is there, operating system is there, CPUs is there. So the metadata related is the information of the system is also here and things like that. And scroll up a little bit, see if there's something important here. Looks like it supports a lot of log files. Scroll up, please. Server containers, plugins, Docker app, buildx, Docker scan. Okay, further up. Looks like we have 8 containers, 2 are stopped, 6 are running. So rather than a quick look at how many containers are running, we can just say Docker info and we can get a quick feel of it. Catching it, buddy?
Yes,
like
yes.
About 39 images so far we have created. Not sure if all the images are physically stored and things like that. And then let's say AUS we don't have. Under the Docker folder, can you do a list? ls warlib docker. Don't have a mount here. Just do ls/mnt. Just say lsmnt without slash, and that one also on the left hand side. Okay. Then we have something called can you do an ls ltr/var/lib/docker and grep for AUF grep pipe and grep. I'm sorry. /var/lib/docker for AUF.
Grep for
A for apple, U for umbrella, F for fox. Yeah. Just do instead of lsltr, do a find. Remove lsltr and type in a find. How about grep for layers? Layer, more precisely. Do find and grep for layer. Okay. So it looks like it's storing in, instead of AUF, it's storing in overlay 2 is the AUF 1. So these are all the layers. When we build it, these are getting created. If you notice, layer SH2. So the image layer and split JSON, a bunch of them, layer DB and things like that. It's also encrypting them, it looks like. And let's see what might be. Go ahead and grep this time for MNT. And where is this one? Docker overlay 2. Overlay 2 is one. So MNT, this is where it's mounting an additional drives data and things like that internally. This is something to be kept in mind, and just giving you an idea, Rahul. We don't have any practicals on this, but just giving you an idea.
Yes.
Sometimes when you're deleting containers and things like that, you may want to force delete them. You try to force delete them, Docker is unable to force delete them. So in such cases, we can also kind of keep in mind, we can manually delete these folders and things like that. Caching.
Yes. Yes.
Okay. And we'll just do a small exercise. Say Docker pull hello world, hello hyphen world, pull hello hyphen world. It should be a small one. Okay. And downloaded it. Okay. Then list the images, Docker images. And let's see. Do we see hello world is there? Okay. Good one. And now list the warlib Docker overlay 2. There should be something called diff folder under the overlay 2, which is inside the Docker. So list slash war slash lib slash Docker slash overlay 2. Okay, listed up here. Bunch of directories, and let's say grep for list again and grep for diff diff. Interesting. Layers, I think we looked at it. Mount, we looked at it. And just type in Docker history. History. Say, list the images, please. Let's take one image already. Maybe let's take the hello world, FEV5, copy that one. And we'll say Docker history, hello world. Okay. So what do you think these two things are, Rahul?
Maybe showing the command it is running inside that container.
Okay. So more precisely, these are nothing but the layers. The first layer is the zero bytes is the first layer. The second one is the second layer. Okay. And let's say voting app, Python app, logo node, Tomcat. List the Tomcat or history the Tomcat, please. Okay. So these are the different kinds of layers with which it was built. Catching it, Rahul?
Yes, yes.
Okay. And let's say, I think we built a application, my web app or something like that. Can you just do a find and grep for web app? Just do a find, it'll find all the files and pipe it and grep it for something like web app. Web app. Fine. Just type in fine.
Enter.
Yeah. Okay, so if you scroll up a little bit, notice it is showing a list of all the files. And this is the example loading app. This is a list file. What we were looking was, if you remember, we created a web app, my web app or something like that. That's what I'm searching for here. So we have messaging, that is worker. Keep scrolling up. Looks like they have some Kubernetes specs here also. Oh, okay. Not much there. Not much really help. But are you understanding how we are using grep, Rahul?
Yes, yes.
Right. And just do a find and grep for Docker file. Okay, bunch of Docker files, example voting app. So we have one worker.net, another one is seed data. Now they gave a separate one for the seed data. That is the one which I think we did not execute. That is one of the reasons. Ideally, that kind of information, the guy who developed it would be having an idea. Earlier, the seed data, I think in the latest version of the voting application, the Docker guys have changed it. Earlier, if you just visit that one, it will automatically just go ahead and populate the table from what I recall. But I think in the latest version, it changed slightly, is what is going on here, Rahul, okay?
Yes.
So when you look at a Docker file like this, when you grab for a Docker file like this, when you look at all these folders, what does that tell you?
It shows the part of that all the Docker files where they are.
More precisely, you can kind of, every time when somebody is building a container, they will generally have the Docker file inside it, right? So here,
yes,
in our file system, these are all the different kinds of apps which are there where they have used the Docker file to build it.
Okay. Okay.
Catching it, buddy?
Yes, yes.
Okay. And okay, history, we have seen it. So the changes, okay. Just type in du-sh 2.6 megabytes. So disk usage is 2.6 megabytes is what it is. du-sh space dot. See if it gives the same thing. Same, I think it's the current directory, how much disk usage it is. But let's say du space hyphen sh star. Okay, so each file, how much it is taking, the memory disk usage is what it is giving. Then let's say, we were looking for a web app file. You didn't happen to find that, did you? I'm sorry.
Yeah, we were searching, but not able to.
We couldn't find it. Okay. Let's see what else can we find. Hello world. It's running the container. We don't have, list the images one more time, please. So there is Tomcat, it is Python, voting app, MCR, result app, Ubuntu. Somewhere we deployed a Python app. The Python, you see there is something called 3.9 Slim Python. So
Yeah, there is.
One more time, scroll up a little bit where we had a grep for Docker files. Is it? No, sorry, down.
Okay.
See, this is an vote and things like that. This is an example voting app. But it's, can you grep for app.py? Find and grep for app.py. Oops, pardon me. It's there in the voting, and voting is that one. Okay. Let me see if I can.
Maybe we have ran that container in the node 1. Maybe that's why we are not able to find it.
Node 1.
Yeah.
Can you quickly log into that one, please?
Yes.
That one. There's a small exercise I would like you to do, which will build up for the next one. And just give me one moment, Rahul.
Yes.
Okay, I'm back, buddy. And
Yeah. So it is there in the node 1. My web.
Going to the directory, my web app. Oh, you're there already?
Yeah.
And Docker file, web app, you have my data, you have. Cat the app.py. So this is just a simple Flask cat where we had a welcome Rahul. And let's VI that file, modify that file, and make a small change in that one. So let's say the main, we will change it to from, just say welcome Rahul Gupta, or instead of Rahul, just say welcome Gupta.
Where? Main. Okay.
Yeah. 1 minute, buddy. Okay. Say welcome. Also save it and quit it. And let's see, Docker, copy the Docker file to Docker file 2.
Copy. Hello.
Just give me one moment, Rahul.
Yes.
Okay, sorry about that. Copy Docker file as Dockerfile 2, just as a backup. Okay, just verify it. And cat the Dockerfile 2. Cat the
That Dockerfile or Dockerfile 2.
Dockerfile 2.
Okay.
So from Ubuntu, we are installing Python. We're upgrading it. We're installing Flask, and I think we have made a slight or a subtle change in app.py, and we are going to run that one. So what we'll do is say docker build space dot docker build space dot -f for fox, and the F is for file, and here you give Dockerfile 2 space -t. Dockerfile 2 space -t for Tom. Enter.
We need to give tag also, -t.
That's it.
Okay.
Oh, the tag gives some name. Okay, so here, if you notice when you're building it, notice wherever it says step 1/6 from Ubuntu, and 2/6 using cache. So layer 2, layer 3, layer 4 have been used from cache. Means earlier when we have brought in the Ubuntu, it downloaded the Ubuntu, it ran it. So at the time of running it, at the time of downloading it and running it, it already has used these layers. So what it is doing is it is reusing these layers. From a slightly architecture, what is happening is when you build a huge Docker image or something like that, a lot of, in order to increase the performance of it, what we can do is we can individually have some of these images built earlier and then run the web app, which is our own app, at a later point of time. So let us say the step 2, step 3, step 4 are taking 2 hours or 3 hours or 4 hours. You can schedule them at a later point of time separately. And then maybe when you come back by tomorrow, you can have these things completed so that you don't have to sit in front of them and have them ready. And these layers are getting cached and reused when you build your web app. Catching the point?
Yes.
So
Means we can schedule the time to build these images now.
So we have, let's say for the sake of simplicity, we scheduled Ubuntu to run yesterday night, and it took, let's say, 4 hours or 5 hours. So by the coming tomorrow or today morning, you have it ready, and now you're building the web app on top of Ubuntu. So now, because the app is built, the layers are cached and they run in a point of a second.
Okay.
Okay, so that's how you make a Docker build fast and things like that. And just say Docker history and give the name of the web app that we gave. So again, that is giving you all the layers and things like that. And that is an idea to keep in mind, or that is something to be kept in mind. Okay, if you want to see what image, you could do a history of that.
Okay.
Okay, another one is, let's say one more time, we'll say Docker run Ubuntu.
Enter.
Yes. Should go fast here, because that's pretty quick. I think it also exists here, but internally there are 3 networks which get created when we create a Docker. And let's see, when we're doing the port mapping, what we are doing is we are accessing these networks internally. Is something to be kept in mind.
Yes.
Okay, so let's say this time we'll say Docker run Ubuntu -- network equals to none. -- network equals to none.
Enter.
Yeah. Okay, so what's up? Failed to create some OCR runtime create failed. Starting container process. Executable file not found in $path home. Strange. By default, if you don't give network, from what I recall, it uses the bridge network. If you say none, by default, the bridge network allows other containers to connect to the container internally. But if you say none, you're explicitly saying, I don't want this container to be connected to anyone. Catching the point, Rahul?
Yes.
Right, it's not working. I don't know. I'll have to look at that. Maybe we need to set up some path or some additional thing in the path or something. But earlier it used to work. I don't know if the latest change could have made any thing. But if you don't want, if you want, when do you think we will use that kind of thing where we don't want a container to be not to be accessible to anyone?
If we want to secure any data which we don't want to share with anyone.
In other words, there's an app. I think we don't want anybody else to be connecting to this one, or there is a team, and they wouldn't like anybody to get into give access to their app from other containers and things like that. You can keep that in mind, that none option. There is something like a none option where we are telling, hey, when nobody else except only this container will be running by itself, and nobody will be connecting to this one. Okay.
Yes. Yes.
Once in a while, here and there, you will get across that kind of things or questions, and they'll probably ask you, hey, is that possible? And your answer should be something like yes, and you should be familiar. If necessary, you may need to look into a little bit and kind of be aware of that. Okay, that's what the objective is.
Okay.
Now, let's say, just say Docker images one more time. These are the images. And let's say Docker PS. None of them. Okay, this is none of them. We don't have anything running here. But I think you can exit out of this one, go back to the, or go to the blue terminal. We have some containers running up there. Yeah. PS here. Docker PS. And let's say Catalina Tomcat. So now what you do, what is Catalina or what is Tomcat is, it's like a web server slash application server that is like an application itself. It is running inside a container is what is going on. Now, let's say do a Docker space inspect and give the container ID. Okay, now grep for, repeat that and grep for, let's say network. Capital N. Okay. So there is a network settings, that is a network ID. And if you just scroll up a little bit, so the networks is right there. It is using the bridge network. You under the networks, you see something called bridge.
Yes.
That is the default one. If bridge is there, that means this is connectable. This container is okay to connect. It's saying that I'm okay. I have a bridge, and notice the IP address and MAC address and things like that. Most likely, you'll be using the IP address for connecting to this one and things like that. And it's something to be kept in mind. If you don't have a bridge and things like that under the networks, if you have something like a none, which means that IP address is not connectable. Catching it, buddy?
Yes, sir.
As simple as that. So that is a little bit about the networking. Okay. Okay. So that completes the Docker. Let's move on to the next one. I'll come here. Back to the AWS and let's go back to the code build. I think yesterday we built a pipeline. Can you access the pipeline?
Yes. Yes.
I think it is pipeline V3. Okay, can you explain me what is going on here?
We are deploying the website which from the S3. Like we have created that zip file and stored it in the S3, which is dev, and from there we are deploying it to the production and using this code pipeline.
Good answer. And we use. Okay, scroll up a little bit. There are a few things you need to be in. Click on the execution ID.
ID.
Which is, yeah, click on that one. Okay. So user code testing admin create pipeline. Okay, 22 hours ago. And there is actions deploy and source are the actions. And these are the actions performed inside a stage. A stage is a group of actions, something. The terminology of the code build CI/CD pipeline you need to keep in mind. Okay, click on the
visualization.
So there is a source. The complete box is referred as the stage. That stage can contain multiple actions inside it. What are the other actions and things like that? We'll try to understand. Click on I for info. Right there. There is an I.
Okay.
Okay, this gives the variable namespace. So these are, its artifact is nothing but a output, and poll source for changes. Okay, is false. So poll source means it's constantly trying to check with the original source and see if it is automatically, if there's any change or not. That's what that represents. S3 bucket is the development bucket. If you recall, that is what is the name we have given.
Yes.
Object key is nothing but the object. The object is nothing but the source code, the zip file.
Yes.
Catching it, buddy?
Yes.
Okay, click on done. This is the source code. Then in deploy, also click on the I. So notice the complete information. These are the deployment variables. Source artifact is input. So input is coming from the source artifact, which is the name which we have given, which you picked up from the previous one. And here we're using a bucket called prod N3. We have also given a public read permission and extract is true because we are giving a zip file.
Yes, yes.
And let's see what else we have. Close this one. Done. Next, on the left-hand side, click on settings. Okay, there is a pipeline that is a service it is using. Expand the artifact store. And below there is something called artifact store.
Okay.
And so there's a region, it is located in that particular region. That should be pretty straightforward. Okay, scroll up, please. Go to the notifications. We can also hook up some notification rules, sending an SMS, sending an email like that. We'll later do this one. Go to the pipeline tags. We can add some keys and values here and there in billing and things like that. We can also make use of these things. But let's see. Give me one moment here. Oh, okay. Why don't you do this, Rahul? Take a maybe short 5-minute or 7-minute break here, please.
Yes.
Thank you. Are you back, Rahul?
Yes, sir.
Okay. Back to the Amazon pipeline.
Yeah.
And let's see. Click on the pipeline on the left-hand side. Okay. So here, by any chance, do you have any idea what is the disabled transition doing?
Disable transition. Yeah, this is the step we are transferring that artifact to this second S3 bucket. That process we call transition, but disable transition.
Good answer. You already answered it. Actually, whatever is there in the source is getting transitioned, as simple as that.
Yeah.
If you need to, you can disable the transition.
Okay.
If you disable the transition, what will happen?
Yeah, so this will not, won't go to that second stage. The artifact.
That's a good one. And oh, okay, I'm back. So now what we'll do is, if you go back to the source bucket, click on the Amazon S3 and the source. And see if you're able to figure out the region. Region is US East, North Virginia, US region.
Yes, sir.
It's okay.
Yeah.
And and also verify the production bucket. And verify the region.
Yes. Not Virginia.
Sure. And come back here. What is the region? The region is the same, right?
Yes.
Do you have any idea if region is different for either the source or the destination, which is a production, for the development or the production? Do you think it will work or it will not work? It's a tough question, but let's see if you're able to take a guess.
It will work, but it will take more time maybe.
It will take more time. Okay, interesting. If you, let's say, if you go back and change the development, try changing the development to another region. In other words, if I would say, try to change the development to another region, how would you do?
Source them. You are saying that I should change that development bucket to different region.
That's right. Oops.
I believe we cannot change the region of that storage.
True. That is why I asked you to look for that. In other words, once you upload it to a bucket, you don't really change the region, you create a new bucket for that, okay?
Yes, yes.
That's something to be kept in mind, because many times developers, when they deploy something and things like that, they come back and they keep asking us to change the region to make it available in a different region and also have it working and things like that is a common thing. So you don't change it, you create a new one. So go ahead and create a new bucket in a different region other than the Northeast Virginia.
So should I create that prod or the?
The source one. Let's say source, and here you have US East North Virginia, right? Select any other region first. Select a different region, maybe US West or California or something like that. We'll select US West California. We'll keep it in because some of the Asia Pacific, they're having some issues. Select that one, California. And in there, in the bucket name, let's say source dev US West hyphen US West. Okay, then ACL is enabled, good one. And we need the unblock the access. This is actually the development, right?
Yeah, we should block it.
Let's see. No, what you do, my bad, will not do this for the development. Will actually name this as prod. Change the source to prod. So I'm sorry, dev to prod.
Create.
And let's say advanced settings, object lock, default encryption. Can you scroll up? We don't need a tag. We don't need the versioning. You acknowledged it. You unblocked it. Good one. Scroll up, please. And ACL's enabled is good. And verify it is US West. Okay. Go to the next.
Create.
Yes. And okay, so let's see. After we create the bucket, go ahead and click on that. And let's see, come back here. Properties. Then if you scroll down, you need to enable the static web hosting. And scroll up a little bit. Did you deploy it? No. You need to go back to static web hosting, edit it. Index.html. Okay, you've already done that. And okay, save changes. And now click on that.
Where here?
Yeah, click on the link. Okay. So we have, okay, so what do you think is the problem now?
We don't have any data there to.
We don't have the data. I mean, data is, okay, we don't have.
No, yeah.
So what do you do if you don't have the data?
We need to upload here and make it public. So then only then we can see it.
Where do you need to upload?
Here. We need to create object upload here.
So in other words, more precisely, this is going to be coming from source. This is not your upload it.
Okay.
We are not uploading it. This is going to be coming from source body. So what is?
Yes. Yeah, we are doing CI/CD, right? That will come from there. Okay.
So what you need to do is you need to create another pipeline, or we can go back to our pipeline and edit that pipeline. Edit the pipeline. This is coming from the US East region, but let's go ahead and edit this. Editing and have you the deploy?
We can maybe delete this stage and create new.
Edit that stage, edit the second stage and say add action. And now let's say, we'll say deploy -US West so that we just have an idea. US West action provider will be S3 because that's where we're going to be hooking it up from. And US West, California, okay, that is where it is. And the source artifact. And the bucket is going to be the dev-source, right?
No, sir, we have edited and created this prod.
Source artifact is coming from.
Yeah. Currently, we are creating that destination, like target.
Okay, go ahead. You also need to extract it.
Done.
One moment. So you chose the bucket as source prod US West. That seems to be good. And if you scroll down a little bit, go into the additional configuration. Canned ACL, we need to give a public read. Okay, and then click on done. Okay, so one is on the one on the left hand side, deploy is deploying to the US East North Virginia. The second action. So these are two actions which are inside a stage. A stage is a group of action. Catching it, buddy.
Okay.
And let's say, I think you can click on done. Save it, save the pipeline. Release the change. Good one. And let's see, scroll down, it's still in progress, okay. Succeeded, and succeeded, cool. Now bring up both of the, start with the, okay, anything, bring up both of them. Just verify if you're able to access it. This is the US region East, okay.
US East.
Yeah, scroll down and access the website.
Yeah.
Okay, access the next one also. Cool. Are you catching the point? We have now deployed it to multiple production regions.
Yes.
Okay, there's also a way to automate this one also. We'll also try to look at that in the coming days and make it available in different regions and so on. Okay, so that is, we modified the region, and let's say back to the pipeline. And go to the scroll up, please. Click on pipelines. Select the pipeline V3, and let's see, there is a delete somewhere over here. Stop execution, edit. Oh, no. So go back. I didn't mean to click on that. Just select that one. Yes, select that and delete pipeline. Click on delete. To confirm delete, type delete. Yes, delete. And no resource updates needed for this source action. I think we can leave that the default. Leave it as it is. What is it? Delete. Put delete there.
Sorry.
Okay. No, you don't need to. Yeah. Click on delete. Cannot read properties of undefined reading configuration. So I think when we are deleting it, there are multiple resources and things like that. But let's say, also we'll get to the, but let's say, cannot read properties of undefined read configuration. So in other words, complete delete. Okay, now keep this window like this. Go back to the Amazon S3 buckets. And see the code pipeline AP South one, East one, and scroll down. Code pipeline US West one. I think it is hooking up to these things from what I recall. So let's say click on US West one. Click on that. Not selected.
So it created this bucket also when we are deploying it to that second region.
Yes. Click on that.
Yeah, I have selected. Or should go to inside. Okay.
Yeah, click that button. Yeah, so there it is. There's a pipeline V3, that's the folder. Scroll, go into that. And source artifact. I think this is, click on that. Click on, so that is zip file. That is zip file where we're getting. Just click on that. And go code pipeline, that is object URL and things like that. But let's say go click on permissions. Access control list. And there is versions. Oh, one moment. Sorry about that. Let me come back. So ideally, from what I recall, let's say, open another window and go to the IAM page. Yeah, open another one. Go to the IAM. And go to the users. See if you can find something related to the code pipeline. The CS, that's not me. That's not me. I think Naveen is the one which is going through the code pipeline.
Maybe we need to delete that bucket then only.
Access management, and we are under the users. Just click on access management on the left hand side on the top. If is it along the upper one? Yeah, just click on that. It will give us a complete summary of it.
No, sir. Please.
It's just expanding. Okay. So go into the roles, please. Click on the roles. So these are the different roles which are getting created, and we are pipeline version 3. US East pipeline version 3. Just sorted by the date so that the ones which are created just now are on the top. One hour ago, EC2 full access for Ansible. Anybody else using our thing? Okay, so basically, I think if you see AWS code pipeline service role US1, US East 1 pipeline V3, select that one and delete it.
This one.
Select it. Let's say there's a delete here, delete. And to confirm each row, enter the role name in the text input field, okay? Copy that, paste that, delete it. Okay, after you deleted it, make sure there is no V3 here. Okay. And let's say another role is, see if there is anything related to the bucket. The source dev or dev underscore source. Is there anything related to that? There is also a West, right? Do you see code pipeline West? We have a pipe one that is for East, V3. We don't see any West here. Okay, go to click on policies on the left-hand side. Even in the policies, see if there is any V3. Yeah, there you go, V3. There is a policy. On the right on the top, the second one also is there. That is the start pipeline US East one. That is the V3, and see for anything else. So I think it's allowing us to select one. So go ahead and delete that. The one and titles is attached to. Okay.
These two.
Yes, please. Okay, now go back to the code pipeline and try deleting it. Still having an error. Oops.
Yeah, it got deleted.
Cool. So that's how we delete a pipeline. Okay. And let's see. Now let me go on to the next topic, which is the code build. Can you stop the share for one moment, please? And give me Okay, give me one moment, Rahul. I'm making a few changes. I'm going to bring up my screen here. Rahul, give me about 5 minutes, buddy. I'm making a few changes to my slides. Please take a short 5-minute break again. Sorry about that. Okay, I'm back. Rahul, are you back, buddy? I'm sharing my screen. Let me know when you're ready. Mira, Kajal, are you there? Can you give me a quick yes, please? Okay. So the next step in the code pipeline is understanding the code build. In order to understand the code build, we need to have a quick idea of the Git. So we'll look at some of the important commands and things like that in the Git, guys. Okay. A brief introduction of Git. It's open source. It is distributed version control. Open source is free. Distributed version control means as version controls are generally centralized management systems where a business or in an enterprise, a group of developers inside that enterprise and business are working on a project, and they're checking in and checking out their files and all the check-ins and checkouts. Or in other words, the modifications that they're performing are being tracked by the version control systems in a centralized location. A distributed version control system is you can be anywhere in the world, and your changes, your modifications, your updates, deletes, all these things are being managed. So that is why it is referred as a distributed version control. By default in Ubuntu and things like that, the Git is automatically installed. What's happening. So it is used to coordinate the work and track the changes in the software development. Not only in software development, in management, and in other scenarios also, we can use the version control, guys. Okay. So it is created for the development of Linux kernel in 2005. Even before 2005, there were other distributed version, or more precisely, there were other version control systems, guys. Git was created in 2005. So again, 90% of the developers use Git. So it is good that you have an idea about that. So the collection of the files and the folders associated with the project along with each file's revision history. So repository is where all the files which are related to a project, whether that is management or whether it is any kind of an artifact, are all stored. That could be files, that could be folders, or a very, very deep group of files and folders together. That is referred as a repository. Commit, a snapshot of a Git repository for a specific point in its timeline used to track the changes. In other words, let's say in about 3 months, we're going to release the product version 1. Let's say in 6 months, we're going to release another, make another release, which is maybe from alpha to beta or beta to gamma, and then the final version and things like that. So what is that? You commit your changes by that. When you commit it, what is happening is your repository becomes a snapshot of all the latest changes and things like that. That snapshot is later built and then released into the production and things like that. So we'll see again what commit is in a bit, guys. Git records the entire contents of each file in every commit. In other words, whether it's a small change or a big change, all the changes are being tracked and they are being saved, so that at a later point of time you could look at all the history of changes that are being done to each file, the code file or whatever that file is. Local repository, the version of the project on your own computer, which you work locally on your own. So when we work with Git in a few minutes, what we are going to be doing is internally the Git will create a local repository. There might be many other people or developers around the world who are working on the set of code that I am working on, that maybe our team is working on. So Git is internally creating a local copy that is referred as a local repository, and the one in the GitHub or in the central location is referred as the remote repository. So what we do is we might make all our changes, we test our changes at our end. Once we feel confident, we can go ahead and also push it to the remote. Each commit is saved to the local repository first. In other words, each commit means each file. There is generally one file or multiple files that the developers work on, and they can be different kinds of files, including the data files, the configuration files, or the source code files. Every time we make a change, we can commit them. When we think we are confident, we can commit them. So all the commits are being performed at a file level, so that again the history is there. Remote repository, the version of the project on the internet or on a network that is kind of acting like a central, but this is most of the times this is a one in the GitHub and things like that. We can have multiple remote repositories for our Git project also. They can be distributed, they can be in one place, they can also be in multiple locations if it is required, guys. Okay, so when we make our changes and when we promote our changes, or when we are trying to check in our changes into the central repository or the remote repository, that is called a push. Push is what after you work, you're pushing it. Pull is opposite. Some changes, it could be possible that the files that I worked on today, by the time I went out to sleep, another set of team or maybe developers have worked during the night time, they modified it, and they have checked it in the central repository or the remote repository. And what do? We pull them. Pull is where you're getting them, is what you can think of. And Git branches allow you to separate your work in a development from the main code master branch. So Git is generally, the branch means generally, we have an application which has maybe features, a few features, and we are in the process of developing a new feature. So what we can do is we can branch it. We can create a branch and try to use that branch as a separate repository. It's acting like a separate repository, and we can plug in our changes into that particular branch and try to test and things like that. That is what is a branch. It's slightly confusing, but we'll see. All new commits will be saved into the branch until you merge it to the master branch. So the branch is separate. We need to again commit these things. It is possible that we are not confident, or it is possible that we have some special conditions why we have to test it separately. So that's why we create a branch. We don't want to check in or commit them. And it may be possible we may also want to revert it back. So what do we do? That's when we can create a branch. We can use the Git tags to mark specific points in the Git history, such as software version. So in other words, every time you make a change, you can tag it, and so you can give some special, the tags act like special names, giving you a high level idea. What are the changes which went into the files or maybe the repositories and things like that. Unlike branches, tags do not have further commits. So generally when you commit it, you add a tag, is what it really means. You can use your own remote Git repositories as source locations on your pipelines if the service providers are supported by the AWS code pipeline. In other words, we can use the Git, we can use, there are other kinds of source code repositories. We can also integrate them with the AWS code pipeline. By default, AWS provides us with AWS code build. That's what we'll look at and we'll try to understand. But there are other kinds of version control systems also that AWS code build supports, and that can be integrated into the AWS pipeline. We can use the master or another branch on your pipeline, short and sweet. We can use it with other things. So there it is, Bitbucket, GitHub. Looks like right now these two, the support for these two is already there, but they are adding more support for the other kinds of providers. So supports these Git service providers for your source action. So the source, the original source code can come from GitHub or Bitbucket. There is direct support here. Okay, then comes the AWS code commit. AWS code commit is the answer for the GitHub from AWS. In other words, instead of using GitHub or maybe other kinds of version control system, we can directly start using the AWS code commit. You commit your changes. That is why it is referred as code commit. So AWS service for hosting private Git repositories. So the repository generally on GitHub, there are a lot of repositories around the world. They're all public, available to anyone, but you can also make them private. So code commit keeps them private by default. It is serverless and fully managed by AWS. In other words, more precisely, serverless means we only pay for what we use. When we don't use it, we don't pay. That is what is the advantage of the cloud. And as a result of that, the costs come down. And also it is highly available, durable, and scalable. These are the advantages of the cloud computing. So in other words, if we are going to manually maintain the code, build servers and things like that, we need to manage, we need to, again, buy the servers, we need to incur a lot of costs, and we need to take care of the high availability. In enterprise applications, the downtime is not really acceptable or not really allowed. So what we need to do is we need to keep our applications. So you need to manually take care of them, whereas those things are managed by AWS. That is a big thing. The durability, scalability. So scalability is when it gets very, very large, when there are lots and lots of applications in your build server. You need to go ahead and scale it up or maybe scale it out. Those things are automatically provided by the AWS is what it is. So no limits on file type or size, but S3 is recommended for files size greater than MB, so 5 MB. So in other words, if your source code, entire source code is greater than 5 MB, then S3 is recommended, but you can also save it anywhere in other sources also, guys. Okay, so standard Git tools and commands are used to access the repositories. That's what we'll try to get a feel of it, how to use the Git tools, Git commands and things like that. Some of the important ones will go. There are lots and lots of commands. We cannot go over everything, but we'll go over the most important things and try to get a feel of it. You can migrate from other Git providers. So in other words, you can also migrate from other existing Git ones. It is designed for collaboration, support branches, pull request notifications. In other words, these are the functions of a version control system. Collaboration. If Rahul is working something and Humira made a change at the same time, what you need to do is you need to merge. So what do? You collaborate with each other, make sure your changes are not messed up, and then you try to check in them, you try to commit them. And if at all, Nitesh comes in and he says, hey, he needs to add a separate feature, but he doesn't get in, maybe this release, maybe he wants more time, so he can create a separate branch and work out of it separately, so that any others changes are not getting into his build, and they don't slow down and things like that. So that's a slightly advanced one. Then you pull the request notifications, you can set them up. We will see that. So it comes with the AWS developer tools and can be integrated. So all these things can be, these are the different kinds of services that it can work with, is what it is. It can be integrated with code build directly. So code commit. So once you commit the code, it is build, and the build is where the build task is performed. You generally maintain a separate build server, and the build can actually pull the source and try to build the application. We can also create a pipeline on AWS code pipeline starting from your code commit repository, which is what we'll see. When we write some code, what we do is you commit it into the code commit. From the code commit, you build it. From build, you go ahead and deploy. So until now, we've been skipping the code build step, but we'll also see in a few in a coming up examples where we will also build it. So data at rest is encrypted with KMS keys. In other words, KMS keys is AWS security management, kind of all the key management service provided by the AWS. So all the data, the keys can be saved here. We can use HTTPS or SSH in Git. So that also we will see. We can grant permissions, create users, and get credentials. So there is only specific users who need to be able to make these commits. Then we can create separate users, give them separate permissions and things like that. We can create separate roles on AWS using the EC2 instances and things like that, guys. Okay, so we'll see how to create the repositories and things like that. Let's say back to you, Rahul.
Yes. So can we take a short break, then we can start?
Go ahead. I'm back, Rahul. Whenever you're ready, you let me know.
Yes.
Great. Share your screen. Okay. So back to AWS console. We'll try to create a code repository and try to understand some of the inner aspects of it.
Okay.
Pardon. Yes. Go ahead and search for code commit. Okay, let's create a new repository. You can call my website rep1. And just give some description, just copy paste the same name, put it into description. It's for sake of discipline, generally a good one. And just add a temporary tag. Okay. And you can enable it for Java and Python. Okay, disable it. For now, we'll not disable it, but generally if it's a Java and a Python, we can enable it. So let's go ahead and create it. HTTPS, there is a Git clone. So by default, it is behind the scenes, going ahead and checking into a Git and taking care of all that stuff. You can click on the SSH. There will be SSH. If you want to use SSH and want to connect to it, we can also do it. And so back to HTTPS, scroll down. There's an add file. Just click on the drop down add file on the right hand side.
Right hand side, add file. Okay.
So if we want, we can create a file. If we want, we can also upload files here, but generally we don't directly do it. We generally have the source code separately and we try to check in here. We'll try to do this later. So scroll up a little bit and click on that clone URL on the top. Clone URL.
This.
Pardon me. Scroll up on the right, top right hand side.
Top right hand side. Okay.
Select the first one, clone HTTPS. Okay. So let's say you can close notifications. And let's see, go back to the repository. So on the left hand side, click on pull requests. It should be empty. We don't have any pulls. Commits, click on commits on the left hand side. Since we have, pardon me. Since we have just started creating it, we don't have any commits. Then next one is branches. As I said, if you want to add a new feature or maybe test it separately in existing code base and things like that, that's when we would create a branch. Then the git tags. And we haven't added, it's not necessary to add it right now. Then the settings. So we have the repository name, repository URL, and let's say go to the notifications. The no notification rules. If you want, we can create it. It's not necessary for us right now. And let's say Check the triggers, repository tags, and Amazon code reviewer. Okay, next one, code reviewer. Ideally, if we had any code, we can associate a repository and actually have them review. Maybe we'll do it in the coming up days, but that is just to get you familiar with that one. Now what we'll do is we'll go back to open another browser or a window with IAM and go into IAM. And IAM, and then select the users. We'll use the Naveen. So click on Naveen. Click on Naveen, the third one. Okay, so these are the permissions. Scroll down, we already have administrator access. So later you can modify it, but for now we'll just keep it like that. Go to the groups. And then go to the tags. Scroll down, then go to security credentials. Let's create a access key. Create a access key, the top one. Yeah.
There are already two active access key. We need to delete one, then only we can.
No, I don't think we need to delete them. You can create another access key.
The option is grayed out, and I'm not able to click it.
Okay, just go ahead and get rid of maybe the first one. Active. Is it still not allowing? Okay, delete the second one also, or yeah. Download it. And now, yeah, close the screen. Okay, and go back to your Git bash. And here we'll go into the blue terminal, exit the root, and go to the G drive, download, exit out of the Ubuntu, go to the local file system. Okay, now go to the G drive and download the source code that we uploaded yesterday, the website.zip. And my website.zip, yeah, download that. Once you download, open it up, unzip it. Okay, look at edit the index.html. You can use anything. Code is good. And we have version 1.0, okay. Okay. Also edit the error dot, no, it's okay. Bring up the terminal here. Or just go to the git bash, that is, will operate from here. Just type in git, enter, which means git is installed. Git verify the version. And so, okay, generally latest version is good. Let's say we need to go into the directory where you have these two. So what I want you to do is, the earlier whatever you unzipped there, unzipped it into a separate directory. Unzip it into maybe my website directory. Don't give space. Just give a hyphen. Oh, that's also good. Okay. You can unzip them. Okay. Verify. Okay. Now go into the in git bash, go into this directory. Okay. Okay. Just do a cat on index.html. And version 1. Okay, looks good. Now say git space init. Enter. So we're initializing the git. This is the first step. So now notice it says master. It has put on the right hand side, by the side of my website, it has put what is called master. So this is like the master branch or master. Git init means you're initializing a git. If you go do an ls-a, now notice what is happening is it created a folder called .git. It initialized git and it keeps saving all the things into this one, all the git related configurations into this particular folder and file. As long as the .git is there, that means this is being managed by the git version control system. It uses it to check in, check out, and commit and other kinds of things and so on. So, but again, we don't really need to go deep into the .git folder. That is just to give you an idea. Now what we'll do, say git space add space dot. Git space add space dot. So you're adding, enter. So you're getting a few warnings, and notice each warning, one, it's HTML file, it is saying warning is okay, error is not okay. So it's complaining something about the internal carriage returns, which is the enter commands and things like that. But let's say now what we are, this is going to add the current files into the local repository. Do a git status. Okay, so it is observing that there are two new files, error and index.html is what it really means. These things need to be committed. They need to be added or committed to the local repository. They also need to be committed into the remote repository, is what it is telling us. These are two new files we just got started. So the next what we'll do is git space commit space -m initialization commit. So this is where we are committing it into the local repository. Just within bracket, within quotes, you give initialization. This is nothing but some comments. Yeah. Now enter. Two files change. Now do a git status. And git status on ban, nothing to commit, working tree clean. So in other words, they are committed into the local repository is what it means. Now what we need to do is we also need to put, now if you go back into the repository, which is my website repository, or whatever that we have given there in AWS. And go into the, click on my website rep 1. Okay, so now notice there is nothing, it is saying HTTPS, scroll down. And on the left hand side, there is something called commits. Click on that. Left hand side, there is left hand side, yeah, commits. And there is nothing here. If you scroll down, nothing is committed here, is what it really means. So now click on the code link on the left hand side. Click on the code link, and on the top right hand side, there is clone URL. Click on that. Select the first one, clone HTTPS. So it copies this one. This link is already copied. Git code commit US East 1. So now what you do, open a new tab and try to paste that one there. Notice it is asking for username and password. So don't enter it, cancel it. In other words, when somebody is going to access this one, it is going to ask this. You can close this one. Close this tab. And now go back to the terminal. And we'll say git space remote space origin. Git space remote add, sorry. Git remote add space origin. Space, paste the URL that you just copied. Enter. And it should give you a new window for asking, so no. So, good to know. Have we done it properly? Okay, oops. Just type in one more time, git space remote, add space origin, space, paste the URL. Oh, what's happening there? When you paste it, it seems to be messing up.
Next line is also getting pasted in the same line. That's happening.
Just press enter. So remote all, okay, that's okay. So we're still okay. It says origin already exists. That is the name we are giving. Now let's say git space push, git space push, space origin, space master. So now push means from our local repository, we're going to put it into the remote repository, enter. It should ask for username. In Windows, it might open up a new window, but let's see. Let's wait for a moment. Just see in Windows, there you go. There's a new window and the below. Yeah, click on that. Now go to the access token that we just downloaded. Yeah, paste the user ID and the token, access key and the secret key. Okay. Let's give it a moment. You will have to delete one. Shrishal, what do you mean, buddy? We deleted 2 of them and we created this brand new, right? Unable to access the requested. Go ahead and copy that URL. Or if you already have it copied, go ahead and go to the tab and just enter that your URL manually. Yeah, clone URL, HTTPS, paste it. Now copy paste username and password here manually. Invalid request, okay. Let's say, what is that one? Let me just check and see. Come here. Type in, just type in git config -- system, git space config -- system. Enter. Enter.
Yes, it is waiting.
Have you done the enter?
Yes, yes.
Is it stuck or something?
Yeah, it got stuck. Maybe you need to.
Say, bring up that command and give a -L. System, no, keep the -- system, space -L, -L for Larry, line. Okay, let's say credential helper is manager core. Okay, type in git config -- system -- unset space credential.helper. Credential.helper. Okay, enter. Could not log config permission denied means, I see. Let's say close this window and reopen another git bash. And go to the directory of ours. Okay, thank you. Sorry about that. Okay, so we're still there. Do a git status. Still in the master, right? And one more time, try to unset that. Git config -- system -unset a hyphen system hyphen. I'll verify that if it is still there. System hyphen L. Yeah. One more time, try to unset it. Unset space credential.helper. Could it Q hyphen unset you gave, right? Bring up the previous command. Oh, there you go. Oh, hyphen, yeah. Remove the hyphen L. Permission. Denied. Okay. Let's see what we can do. One moment, let me come back here. Just look into it. Give me one moment here. Okay. Can you try running this one? Can you try git space remote rm space origin? Git space. Are you there? Okay, sorry about that.
This terminal got stuck. Maybe we need to.
Okay. Give it a moment.
Maybe. Should I create new git dash?
Okay, yeah, I had the same thing. Can you create a new repository?
Yes.
No. What I mean is, you're opening a new terminal. Okay, continue. Just give it a try. Go to the directory. I think it's in documents, right? Okay. So it looks like you're already in the git here because the .git is there. So try git space remote space RM, space origin. Enter. LS. Okay. We still have the master. That means it's still in this one. Try git space, or sorry, type in RM-RF, RM space -RF, space dot git. Enter. Okay, now if you notice, we removed the dot git and notice the master is no longer appearing. So it is thinking we are not in the git. We still have our source code error and index.html. So we'll redo this process one more time. Just type in, start with git init. And initialize empty. So that is initializing the local repository. Next, say git space add space dot. Okay, git status. New files. Okay, git commit. Git space commit space -m space say initialization. In the meantime, go to the URL and copy the clone URL one more time. You can copy that one. Right. Okay. So we have done then say we need to, so the things are added to the local repository. Now we need to add it to the remote repository. So say git space remote space add, remote add origin space and paste the URL. Oh, wait one moment. Before you do this one, just say git config system -URL. So -- system -l git config -system -l. Verify this one. Okay, enter. We still have the credential helper here. Try unset one more time. Git config -system -unset credential.helper. Unset. It's still logged up. Okay, let's see. Okay, never mind. Go ahead and we'll just one more time to push it. So say git remote add. Git remote add origin and then paste the URL. Origin space paste the URL. Okay, enter. Should come up with the username and the password. Now push it. Git push. Origin master. Enter. Should ask for username. Okay, enter the username and the tokens. And make sure you're copying it properly. Okay. Looks good. Okay. (403). Can you go back to the code commit on AWS console? HTTP. There is a code. Scroll down. My website. Scroll down. Nothing here. Go to the pull requests on the left hand side. None of this. Go to settings, please. Where did we create? Where did we create the notification access tokens? Create access key. Scroll down, please. HTTP. Oh, okay, my bad. HTTPS Git credentials. Okay. Yeah, I think this is a common thing generally. I keep coming across. We are generally going ahead and creating the upper ones. It is these things we need to create. Sorry about that. We won't be able to look at this one, right? The Naveen at 1620. We won't be able to copy paste that, right? Are you able to download that by any chance? Select that and see if it's allowed.
Yeah, we cannot. Maybe we cannot access this one. We need to generate.
Generate a new one, please. Yeah, this is a common thing I generally do, and I also see others are getting stuck here. Just keep that in the mind, Rahul. Now, let's use this one for the credentials. Not push, no, not push. You again one more time, git remote add. We'll wait for this. Oh, okay. Now give the username and password. Pardon me. Good. So now, if you go back to the AWS console and go to the code commit, refresh that page. Click on code. Good. Refresh. Okay. Let's see. So there is error.html and click on index.html. Verify it's everything looks good there. So there is website version 1. Okay. So now what we'll do, come back to the git bash and we need to say push, git push origin master. You already done that? I think you already done. What did you do? Git push origin master is done. Yeah, the push is the one which is pushing it and putting it. So now you need to go back to the, we have verified the repo and we need to bring up the website. Before you bring up the website, go to the commits on the left hand side on the console. Click on that. No, on the left hand side, commit ID. Yeah. And scroll down. So there is the error, scroll down. There is index, scroll down. So there is only one commit. So right now we don't have anything more to look at. Now we need to go and browse the, so let's see, there it is. I think we may need to go back to the website. So go back to the bucket. We have built it. What is this one? Sorry. What we also need to do, we need to hook up the bucket. We haven't hooked up the bucket. So we need to create a pipeline. Sorry about that. Go ahead and create a new pipeline. And pipeline, just give something. Pipeline V4 maybe. And now the default, choose the default location. Scroll up a little bit above. New service, okay. Click on next. Source provider is going to be Amazon S3. We'll hook it up to the prod.
So this time code commit must be the source provider.
Yeah, my bad. Sorry about that. We'll go back. Good catch there. Sorry about that. Yeah, select code commit right there. Code commit. Repository name is whatever we have given just on my website repon. Okay. Branch name is going to be a master. You can select the CloudWatch as a default. Click on next. You can skip the build stage again. Deploy is going to be in S3. And yeah, that is okay. Bucket is, we'll give that, what is that? Website prod, I think. So source underscore prod, I think. Prod N3, okay, let's go with, yeah, let's go with N3. Extract the files. And additional configuration. Public read, click on next. Build stage deploy is okay. Extracting true, we have given source prod N3 public read, okay. Create the pipeline. In progress, let's give it a moment. Scroll down, please. Succeeded the deployment, okay. Now, yeah, click on that one. Then you need to go into the properties, I think. Bring it up. Okay. So now what we have done is we have some code in, we have deployed it using the code build. So in other words, from our git bash, we made some changes to the code and we checked in. Checked in means we committed to the local repository, then we pushed it to the remote repository, and then we created a pipeline. The pipeline, what it has done is, since we have told we wanted to get it from commit, code commit, it brought the code, instead of Amazon S3, it brought it from the code commit, which is the so source code repository, and it deployed it into the prod, and in the prod, it automatically deployed it, and it is we are able to look at the application. Are you catching the point, Rahul?
Yes, sir.
And what about others, Humera and others? Are you able to catch it? Okay, and now what will happen is The daily life cycle is we're going to be making multiple changes. Multiple developers are going to be making multiple changes. They're going to add the files. They're going to remove the files into the local repositories and the remote repositories. So what we need to do is, so now as and when they do it, what will happen is the whenever the push is done to the remote repository, whenever the change is detected, the AWS code pipeline is automatically triggered and deployed whenever the new changes are coming in. That we will save it for tomorrow. Catching it. Pardon me. Catching it, Rahul.
Yes, yes.
Okay. So, Humira, Nitish, are you catching what I'm saying? Okay. We'll save that for tomorrow. Any questions today, guys? How is it different? Earlier, we have our source code was it on S3. In code commit, in source, if it is there on S3, you need to manually put it into S3. Whereas if it is in code commit, it is automatically coming up. You need to manually deploy it into S3 and then the pipeline will pick up. Here, as you put it into the code commit, it will automatically pick up. Of course, it's almost the same, but just a subtle difference is to be there to be more precise, Srishal. That's a good question, actually. Even in S3, when we are manually putting it, that is where we are pushing it. Actually, if the size of the code is higher, we will actually get it from S3 only. If it is greater than 5 megabytes and things like that. So the only difference is the source is different. And most of the times the source code might be less than 5 MB. It's not necessary and things like that because the code is generally not really huge. 5 MB is a pretty big one. Is another quick thing that I can think of. Catching it, Srisha. Okay. Okay, guys. Rahul, if you don't have any questions, we'll wrap it up here for today.
Yes.
Take care, stay safe, and keep learning. Cool, buddy.
Thank you. Thank you, sir.
Thank you. Signing off for today, guys. Thank you again. Bye for now. Thank you.